Let us start with the Correlogram. Means we are going to talk about tests of autocorrelation and stationarity of time series, right? But let me tell you, people, that stationarity is not a problem. Rather, it's a desired property of a time series. Okay, we need stationary time series to get some stable long run forecast, right? If time series is not stationary, then your forecast will not be reliable, it won't be stable. Now, issue arises that how to test for the stationarity or absence of autocorrelation, because stationarity means absence of autocorrelation or the existence of sometimes negative autocorrelation that your series is converged. I will explain the stationarity concept after this lecture. Let us first of all discuss the tests of stationarity are based on basically they are categorized into two types. They are classified into two categories. The very first is autocorrelation function or Correlogram based testing. And number two is the unit root testing, unit root based testing, right? So two types of tests are suggested to see whether a series is time series stationary or not. So first of all, we'll be talking about autocorrelation functional parallelogram based testing. Let us first of all talk about ACF, that is autocorrelation function based parallelogram based testing, right? So what is parallelogram basically, and what is autocorrelation function? Let me show you. Uh, hope you remember yesterday I told you people that what is row cap. This is summation et minus 1 upon summation et square, right? This is the row cap, the autocorrelation coefficient, right? Now this autocorrelation function can be computed with the help of autocovariance, like we talk about rho k cap is equal to is equal to gamma t minus k upon 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 gamma naught cap. So what is gamma t minus k and gamma naught cap? Let me show you. They are basically auto covariances where gamma gamma t minus k cap is equal to summation et minus k. Obviously t is equal to 1 to capital T will be the summation upon summation, yeah, upon n. Upon capital T, we can write T are the number of observation. T is number of periods oblique observations, right? Basically, this is autocovariance. Obviously, if k is equal to 0, then this is not mm, this is called gamma k cap. Yes, uh, gamma k cap is gamma k cap upon gamma naught cap, right? So gamma k cap is summation t is equal to 1 to capital T et minus k upon capital T. Okay, where t is the number of periods oblique observations. If k is equal to 0, then obviously you can write it as gamma 0 cap is equal to summation t is equal to 1 to capital T et square बन जाएगा. It will be et square upon t, right? So, where we can say that where gamma naught cap is variance or error variance, right? And gamma k cap, now if k is unity, then if k is unity, then gamma 1 cap would be summation et minus 1 upon summation upon capital T, right बच्चे? Similarly, gamma 2 cap will be summation et minus 2, okay, divided by t. Summation you can make this loop operator that t is equal to 1 to capital T, or that is understood, okay. So for tth period, we can compute gamma this, say for period t minus 1 will be summation et minus t minus 1 upon t, so on. Now for each period, a autocovariance coefficient can be computed. So all these gammas are autocovariance coefficients, and to get the autocorrelation coefficient, what we are doing, rho k cap, I am telling you, rho k cap is equal to gamma k cap upon gamma naught cap, right? So rho 1 means autocorrelation of first lag will be, tell me, what would be the formula? Summation et minus 1 upon t whole divided by summation et square upon t. T and t will be cancelled out. Can I write it as summation et minus 1 upon summation et square? Okay, this is my autocorrelation coefficient with lag 1. With lag 2, if I have to compute, okay, what I can write is gamma 2 cap upon gamma naught cap. This would be summation et minus 2 upon summation et square, because t and t will be cancelled out. If you want, then I can put t here. This would be cancelled out. This is rho 2 cap. So for each period we can compute. For third lag we can compute row 3 cap as this, and so on. But this is called autocorrelation function. Okay, autocorrelation function. So we can say that this autocorrelation is the function of lag k. Okay, means as k is changing, this autocorrelation is changing, right? Means obviously autocovariance is changing. That's why this autocorrelation is changing. This is called autocorrelation function. Okay, hence rho k cap is equal to f of k. That is autocorrelation of period t with lag t minus k is the function of lag k. Okay, this function is called autocorrelation function, right? Now this rho k cap is normally distributed with mean 0 and variance 1 by n, or 1 by t, you can say. Okay, t is the number of years, capital T. Now if this is the case, rho k cap is normally distributed with mean 0 and variance 1 upon t. If I have to consider the confidence interval for rho cap, okay, then can I write it as because it is if you remember that formula for this rho k cap is rho k cap plus minus z 0.05 standard error of rho k cap, right? Now, since rho k cap is having mean 0, so 0 plus minus z 0.05, standard error is under root variance. Under root variance is under root 1 upon t. So, my rho cap will be distributed with, if I'm using z 0.05 as 1.96, can I write it as minus 1.96 into under root 1 upon t less than equal to rho cap less than equal to 1.96 under root 1 upon t. This would be the confidence interval for rho cap, for each rho cap. Okay, so what we will be doing, we will be plotting. So this is autocorrelation function, and for each autocorrelation we have constructed the confidence bound. What we will be doing, if we plot this rho k cap against lag k, but this is called autocorrelation, this is called Correlogram. Okay, this is called Correlogram. Obviously this is 0 minus unity to unity. Okay, this will be the axis. K lag 1, lag 2, lag 3, lag 4, lag 5, and so on. Lag 6, lag 7, up to means whatever the lag you want to compute the correlation coefficient, you can compute. The lag 1, 2, 3, 4, 5, 6, 7, and so on. We can compute for up to say t period lags. Suppose the first now we have to plot confidence interval also. Probably this would be 1.96 into under root 1 upon t. Okay, the upper bound of the confidence interval, the dotted line. This is minus 1.96 under root 1 upon t. Okay, the confidence bound is plotted. Suppose the first autocorrelation is this much. Suppose this is going beyond the upper confidence interval. The second is this one for second leg. For third leg, this is this. Over a period of time, as lag will increase, the autocorrelation will fall. It must fall rather. Okay. So the series is oscillating. But we can observe that over a period of time, this autocorrelation is falling, and for lag 1, your autocorrelation is positive and beyond the upper confidence interval limit. So we can say that if series of this type that we have plotted, then there exists autocorrelation of order 1, because for first lag, autocorrelation is positive. It may be possible that for further lags like lag 2, lag 3, lag 4, 5, 6, 7, this autocorrelation exists. If any of these bar will exceed the confidence bound, then that correlation will that order of autocorrelation will exist. But if this is called Correlogram that we have constructed manually, well, let us construct this autocorrelation function and Correlogram with the help of Gretl. So I will be opening this Gretl. Let us open the same data file that we had opened yesterday. Go to File, Open Data. We have time series 1.xls that we had opened yesterday. Okay. I want to give the time series interpretation forward. Hope you remember monthly forward 1991 month 4 was the starting date. 1991 month 4 is the starting date of my data. Forward, apply. Now it is open. Now let us suppose I want to see whether there exists autocorrelation in M3 series, okay, or not. I'm saying autocorrelation in M3 series. I'm not saying simple autocorrelation, because simple autocorrelation means if I am estimating a model y on x and I am testing existence of autocorrelation in that model, then obviously I will have to construct a residual series and apply that that parallelogram testing on the residual series. So first of all, let us see whether can we construct parallelogram for M3 series or not. Right click on LM3 series. Right click on LM3 series. See, there is option of parallelogram. Click here for how many periods you want to construct this parallelogram. For 24 period, I think that much is sufficient, because we have a huge data, and up to 24 periods parallelogram means for 24 months autocorrelation can be detected. Click OK. Once you will click OK, you may observe we have autocorrelation function ACF and partial autocorrelation function. Okay. Q statistics have been given for these partial autocorrelation function with a p-value 0.000. Basically, these Q statistics have been computed for ACF, not for PACF. Okay. These are statistically significant. That's why you can see the 3 stars with ACF function. But let me tell you what we have to see. We have to see this partial autocorrelation function. We can observe that partial autocorrelation, a positive partial autocorrelation of lag 1 exists, and all other partial autocorrelation coefficients are statistically insignificant, because these stars are not available with those partial autocorrelation coefficients, obviously we can conclude that an autocorrelation of order 1 exists. Okay, अगर कोई भी बच्चे higher lag with higher lag, partial autocorrelation coefficients of higher lag, some stars would have been appeared. We can say that we had concluded rather that correlation exists for a higher order of lags, but since the partial autocorrelation coefficient of with lag 1 is statistically significant and all other are statistically insignificant, we can conclude that a partial autocorrelation of order 1 exists, okay, or autocorrelation of order 1 exists. If we have to see the correlogram, this correlogram is available. This correlogram is available. Okay. We can save this if you want to save this graph in any format. You can click here. See, these three lines are menu lines are appearing at the lower bottom of at the right bottom of this autocorrelation function graph, or what we say, the correlogram. Click here, save as PNG, PS, EMF, PDF. I save in the PDF format. Okay, save desktop. I'm going to save the graph session INP. This has been saved. Okay, let us see this graph. Graph has been saved. Now I will be giving you the better picture of this graph. This is ACF plot. You may see the ACF plot, and obviously these are the confidence bounds. All ACFs are above this limit. See, okay. Here you can observe. See, this is the main issue. You can see that these two lines, the red lines are the confidence bounds, the upper confidence bound and lower confidence bound, and this is green graph. Obviously, for order 1, this green positive graph has been observed. All other green graphs are very low and they are below. You can say they are within the confidence bound. So ultimately, we can say that autocorrelation of order 1 exists in this LM3 regression equation, LM3 time series. So, bache, let this is about construction of autocorrelation function as well as the correlogram. If even if we have to estimate the model, we can go ahead with the estimation of model. IIP, CMR, LER, the three independent variables we are taking, LM3 dependent variable we are taking, click OK. Okay. Save residual series. I'm going to save. This is the name of the residual series. Hope you have observed the means after estimating the model with OLS, go to save, to click residual. Now this would be the residual from model 1. Name, you can give your name, like I'm giving residual. Okay, click OK. See, residual series has been constructed. Okay, now once residual series has been constructed, right click on residual series, construct correlogram, click OK. Now this is the correlogram function, and we may observe that there exists huge autocorrelation in this function. If we see partial autocorrelation function, these coefficients are first two coefficients are positive as well as statistically significant. Third is not. Fourth is negative. Then so on. For sixth period, this positive autocorrelation is observed, significant. For ninth, for 12th, for 13th, and so on. Means we can observe autocorrelation up to 19 lakhs, right? We can observe autocorrelation up to 19 lags. So this is a serious autocorrelation problem in this estimation, since residual is highly autocorrelated. We can save this graph also. Let us save in PDF format, so as I can give you, or I can directly give you the preview. See, this is the preview if I save in the PDF format, and you may observe PACF graph. Okay, the Correlogram. You can see many green plots are exceeding the confidence bound. See, for first lag, for second lag, and for many lags, these plots are exceeding these confidence bounds. So ultimately, there exists a serious problem of autocorrelation when I am estimating the model like. Hope it is clear from preview that when I am estimating a model where the model 1 has been constructed like when I estimated this OLS model where LM3 is dependent upon LIP, LCM or LER. Okay, so this estimation is highly it is basic. These are basically spurious estimates because why spurious estimates? Because there exists huge autocorrelation from Correlogram. We have seen what type of autocorrelation exists. This you can see huge autocorrelation. Many green bars are exceeding. Basically, this is a plot of the residual of this estimation. And Durbin Watson, you may observe it's very low, not near 2. We had computed that around zero point 0.5 something value was there for autocorrelation function when we computed autocorrelation using this relationship. Okay, and that is the autocorrelation of order 1 that we can compute with the help of Durbin Watson statistics. Auto This Correlogram is giving us the clear picture that what type of autocorrelation exists. It exists with for so many lags. This autocorrelation exists. So this estimation is not reliable. We can't go ahead with these estimates. Ultimately, we have to give some time series treatment, some other time series models we need to use so as we can judge the relationship among these variables. Okay, Bache? Thank you so much. This was the today's lecture on calculation of autocorrelation function as well as construction of Correlogram. Thank you so much, Bache. Now I will be taking your attendance. Uh, Let me stop.